Lesson 2.3, Introduction to Functions. So what is a function? A function is a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. The domain of a function is a set of all possible values of the first variable, while the range of a function is a set of all possible values of the second variable. And here are two examples of functions. There is perimeter being p equals 4s and area being a equals s squared. So moving on to our first example, state whether the data in each table represents a function and explain. So for A, you can see that there is exactly only one value of y for each x value in the table. Therefore, the data set represents a function. However, in B, when x equals 3, there are 3 different types of y values. Therefore, the data set does not represent a function. And in example 2, state whether each graph represents a function and explain. For A, when you do the vertical line test, you can see that for one x value, there can be multiple y values. Therefore, the graph does not represent a function. And in B, when you do the vertical line test again, you can see that for each x value, there's only one y value, meaning that the graph represents a function. What is a relation? A function is a special type of relation. A relationship between two variables such that each value of the first variable is paired with one or more values of the second variable is called a relation. And in example 5, evaluate f of x equals 0.5x squared minus 3x plus 2 for x equals 4 and x equals 2.5. Simply, you would plug in 4 first into the x value of the equation to get f of 4 equals negative 2. And similarly, you would plug in 2.5 into the x to get f of 2.5 equals negative 2.375. And to check your solutions, you can use a graphing calculator. Moving on to lesson 2.4, operations with functions. So there are 4 different types of operations with functions. For all functions of f and g, there is the sum, difference, product, and quotient. And you can see on the screen the examples. For example 1, let f of x equals 5x squared minus 2x plus 3 and g of x equals 4x squared plus 7x minus 5. A, find f plus g. So for this one, you would just add the two expressions together and simplify by combining like terms to get 9x squared plus 5x minus 2. And for b, you would subtract the two expressions and distribute the negative to get x squared minus 9x plus 8 when simplified. Example 2, let f of x equals 5x squared and g of x equal 3x minus 1. A, find f times g. So you would multiply the two expressions together and distribute to get 15x cubed minus 5x squared. And for b, find f divided by g and state any domain restrictions. So when you simplify f of g of x, you would get f of x is over g of x, where g of x is not equal to 0. And that would give you 5x squared divided by 3x minus 1. And on the side of the blue text box, you can see how they found that x does not equal to 1/3 because that would give the function as undefined. Composition of functions. Let f and g be functions of x. The composition of f with g, denoted by f symbol g, is defined by f of g of x. The domain of y equals f of g of x is a set of domain values of g whose range values are in the domain of f. The function f symbol g is called the composite function of f with g. Example 3, let f of x equals x squared minus 1 and g of x equals 3x. A, find f composite g. And to get the solution, you would just plug in 3x into the function of f, and you would get 3x squared minus 1 simplifying it to 9x squared minus 1. And similarly for b, you would plug in the whole function of f into g to get g of x squared minus 1. And you would multiply 3 times x squared minus 1 and distribute to get 3x squared minus 3. Thank you.